Hello and welcome to the course Design Borefields with Confidence. This is the introduction video of the fifth part of this course, but before we jump into what we'll be covering next, I want to recap what we've been doing in part 4. Now in part 4, we for the first time moved our focus away from the thermal design of borefields towards the hydraulic design. And for that we introduced the concept of the pressure drop in the first chapter of the last part. Now, we said that the pressure drop, that it consists of, on the one hand, local losses, minor losses, and these are the bends, the junctions, and so forth, and on the other hand, the friction losses, the major losses, due to the fact that we have fluid with a certain viscosity flowing through a pipe. And together, these minor and major losses, they come together in the total pressure drop that is important for your pump selection and so forth. And we also expressed some relationships between the pressure drop and the flow rate, which was a quadratic relationship, as well as the relation between the pressure drop and the pipe diameter, where we said that when our pipe diameter decreases, our pressure drop increases to the fifth power. So that was also a very strong relationship. In the second chapter, we then moved away from the theoretical foundations of pressure drop to pressure drop in the context of borefield design in JHE2. Because as you already know, we have now variable fluid properties, variable flow rates, so our pressure drop is also not constant over time. It varies from hour to hour, and this also means that if you're designing your borefield or you're calculating the pressure drop, that you have to care about both heating and cooling, because both can have different pressure drops coming with them. And we also introduced the concept of pump power and pump energy, and we said that if you are working with a constant flow rate, we showed that you then have a way higher total pump energy consumption than if you're working with a variable flow rate. Now, the last chapter of the last part was all about the hydraulic connections between your boreholes. And we started with the concept of hydraulic balance. So, if you have a certain borefield, the question was, how can you create or calculate the pressure drop for that entire borefield? And due to the concept of hydraulic balancing, where you say, well, I want the same flow rate through every borehole, so I have the same pressure drop, what you need to do is you just need to calculate the worst case situation, the borehole that's the furthest away from your manifold. You calculate the pressure drop for that, and then you know the pressure drop for your entire system. And we did that for Tickleman connections, series connection, and also direct connections. So that was the whole pressure drop aspect of borefield design. Now, in this fifth part, we will use both the hydraulic and the thermal insights we got in the concepts of borehole resistance, heat functions, and so forth, to really get some insights in, how a borefield can be designed. And we will start off this part with two chapters on a very important and very common question, namely, which one is better, a single or a W tube? Now, I know that there are other designs as well, and you have coaxial probes and innovative solutions as well, and we will cover them later. But these simple questions, single or W tube, will teach us quite a lot on both how the borehole thermal resistance varies depending on your design choices, as well as the hydraulic counterpart, the pressure drop, and so forth. And that will be the first two chapters of this part. Next, what we will do is we will talk about the importance of calculating with the correct grid, the correct configurations of your borefield. Because often we are used to working with regular configurations, rectangles, and so forth, and we do not really take into account how the boreholes are placed in practice. But as we will discuss, this can really play a role. And we will also show you how you can draw your coordinates in, for example, AutoCAD, and import them into JHE2 Cloud to make your workflow a little bit easier. And we will end this part with a rather short chapter around the question, well, how can you cope with imbalance? And we said imbalance is the difference between the energy being extracted from the ground and being injected to it. So it determines the long-term temperature drift of your geothermal system. And given the insights from the other chapters, we will have gained some extra knowledge on how we can cope with imbalance and see some interesting things popping up there. So I hope you're buckled up for this fifth chapter. Let's get started with the question, what's better, the single or the W tube?